It's 7:05, so I will go ahead and share my screen. Okay. So today, we're going to be talking about analytic geometry. I would say it's more about applying the stuff that we've learned over the past few weeks and applying them to more complex problems, I think. So yeah, with that, we can go ahead and get started. So first we have 17.1, which is about lines. And I feel like at this point we know a lot about lines, but we're just going to go back and do some algebra review, and we'll just start from there. Okay, so the graph and equation that has x and y variables consists of all points x and y on the Cartesian plane that go along with the given equation. So I think we've all come across these different forms of equations, such as the linear equation, where the form is ax plus by equals c, and a, b, and c are constants, and a and b are not both 0. Here's an example of the linear equation being applied, or they're actually, values instead of a, b, and c. And the x-intercept is the point where the graph intersects the x-axis. There can be more than one x-intercept. There can be none. There can be an infinite amount. It just depends on the graph. On the right, the x-intercept is 3, 0. And then the y-intercept is just this. It's almost the same thing as the x-intercept, but it's the point where the graph intersects the y-axis. And same thing with the y-axis, y-intercepts. There can be more than one y-intercept. There can be 0, or there can be an infinite amount. And on the right, the y-intercept is it's at the point 0, 2. And the slope of the line is the, I guess one way you could say is the direction of the line, but it's like, it's defined as m. That's the variable that we would use to call the slope. But for example, in this one, one way you could figure out the slope is, you go down 2, and then you go to the right 3, and then because you go down twice, that's -2, and then you go to the right 3 times, that's positive. So then the slope would be -2 or 3, because the slope form is always x over y. And for this is a, let's see, I'm pretty sure that's called point slope form. Yes. Or okay, I'm going to go over the all of the forms of, oh wait, actually, no, sorry. I'm getting ahead of myself. But as for the slope, as I was saying, to figure out what the slope is, if you have 2 different points, what you would do is y2 minus y1 over x2 minus x1. Sorry, I thought we were looking at point slope form for some reason when I was looking down here, but no, it's just the formula for slope. But yeah, pretty straightforward. This should all be stuff that we've come across before, and I would say pre-algebra.
Just a question, does anybody have an introduction to geometry book?
Wait, are you asking the entire class or?
Yes. I have a question.
Why are you asking?
Because I just want to know if I just wanted to know if Alvin is getting the solutions from the solutions manual.
No.
Okay.
Okay. So here we have more review. So this is on the left, we have a line with a positive slope. On the right, we have a line with a negative slope. And a slope of a horizontal line, that's just completely straight, that's 0. And the slope of a vertical line, that's it intersects the x-axis. It's a perpendicular. It forms a 90-degree angle with an x-axis that would be undefined. And the greater the magnitude of the slope of a line, the steeper the line is. And Okay, we can go to the next slide. So okay, here we have the different forms of a linear equation, I guess you could say. But first we have point slope form. Y minus y1 equals m times x minus x1, where m is the slope of the line, and then y1 and x1 would be it would be a set of 1 point, and you would plug in those values into the corresponding y and x values. And the standard form is, we just went over this a few slides before, but it's ax plus by equals c, where if possible, a, b, and c are integers, a is positive, and a, b, and c have no common factors other than 1. The slope-intercept form is y equals mx plus b, where m is the line slope and b is the y-coordinate of the y-intercept. I think this is probably the most common form that comes into your heads when you think about, a linear equation. What would that look like? I think the slope-intercept form is the most commonly used form of a linear equation. And we have distance formula, midpoint formulas. Those are, I would say, I think they're more commonly used in algebra. I mean, geometry is more focused on different shapes and just different concepts. But I just wanted to include those formulas here. So the distance formula is the distance in the plane between points x1, y1, and x2, y2. And that would be the square root of x2 minus x1 squared plus y2 minus, that should say y1 squared. And the midpoint formula is basically it's the midpoints of a segment with endpoints x1, y1, and x2, y2. So that would be x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So what you're doing is just you can think of it in this way, but you're taking the average of x1 and x2 and then y1 and y2, and that would be your new the new point that you get. That'll be your midpoint. And I'll go ahead and fix the y2 minus y1. Okay. Oh, great. I'll leave this up here for like a few more seconds and then we can go to our first problem. Okay. We can always go back to that slide in case we need to look over those formulas. So problem 17.1, we want to find an equation whose graph is a line that passes through the points -1, 7, and -5, -3. Does anybody have any ideas as to how we would solve this problem?
Yeah.
Yes. Okay, go ahead.
So it passes through the points -1, 7, and -5, -3. So basically, you first find the slope, the rise divided by the run. The rise is a 10, and let me see. Wait, the rise is -10, and the run is -4. So the slope is 5/2. Oh, okay. So the slope is 5/2, and then the first point is -1. So, and then then basically we have to find the y-intercept. The y-intercept is the point where x equals 0. So we have to, the first point is -1, 7.
Mm-hmm.
If we, and then we have to increase -1 by 1 to get the point where x is 0. To increase the x by 1, the y coordinate has to be increased by 5/2, since the slope is 5/2. So I did 7 plus 5/2, and that's 19/2, and that's what that's what Alika got, or how do I pronounce your name?
Relica? Is that
I got the
Yeah.
same thing as.
okay? That's one way you could do it. I think another way you could do it is actually this might be a simpler way. I don't know. It just depends on your preference. But you can just take one of the two sets of the points. So we can just say -1 and 7, and then we can just plug it into the point slope form because we know what the slope is and we have one set of points. So then it would be y minus 7 equals 5 divided by 2 parentheses x minus -1. And then you would just have to simplify this. But if your teacher doesn't specify what form he or she wants you to answer in, like if your teacher wants you to write it in for example standard form, or if she wants you to write in slope intercept form, then you would have to simplify it. But if she doesn't, then technically, or she or he doesn't, then technically you can just leave in this form. So yeah, this is just, you would just plug in the numbers because you already have the numbers. But that's also another way that you could find the equation of the graph by figuring out what the y-intercept is. Okay, I'll leave this up here for a few more seconds and then we can go on to the next slide. Okay. So this is also kind of review parallel and perpendicular lines. We've dealt with these types of lines a lot. Okay, so if two lines have the same slope, then they are parallel. At the same time, if two non-vertical lines are parallel, then they have the same slope. If two non-vertical lines are perpendicular, then the product of their slope is -1. At the same time, if their product of the slopes of two lines is -1, then the two lines are perpendicular. So these are two concepts that you should, I'm pretty sure you would have learned in pre-algebra, where if the slopes are the same, then the lines are perpendicular, and then if you have two different slopes, then yeah, their product is -1, then they're perpendicular. The two lines are perpendicular to each other. Okay. So next, we're going to be talking about circles. Oh, I forgot to talk about the schedule, but it's basically the norm at this point. We're going to be talking about analytic geometry until 7:45, take a 5-minute break, keep lecturing, and then maybe around 8:12 or something like that, or 8, I don't know, or between 8:10 and 8:15, we can start playing Kahoot. Okay, so I don't know if we have talked about the standard form of the equation for a circle. But if we haven't, then this is new stuff for you guys. But yeah, so the standard form of an equation whose graph is a circle is x minus h squared plus y minus k squared equals r squared, where h, k, and r are constants, with r being greater than 0. And basically, hk, that would be the point where it's going to be the circle center. So you would just plug h into h and then k into k in the equation. And then the circle's radius is going to be r. So whatever, for example, let's say you had, Well, okay. I can come up with an example later, and I think we're going to deal with more examples or problems relating to circles. But if the radius was 6, then you would square that, so then you would get 36. And then if you had a circle where the center was 4, 6, for example, then it would be x minus 4 squared plus y minus 6 squared. Okay. So next we have this problem, and we want to find the area of the region that is enclosed by the graph of the following equation. This is kind of more in the difficult side to imagine, so I'll go ahead and use Desmos to this.
Can you go back to the equation for the area?
Here, let me plug in the equation. 2x squared minus 8x plus 2y squared plus 16. I don't know if it's going to. There we go. Okay.
Whose dog is barking?
It's my dog.
Her dog.
He's very loud. Sorry, what slide did you want to go back to?
The equation for a area of the circle on a graph.
Or you mean the standard form?
Yes.
Okay.
Now your screen's a little bit frozen. Oh, it's not frozen.
It's not, okay, there. Okay, so it's x minus h squared plus y minus k squared equals r squared. When I first saw this equation, I was a little bit like, oh, this kind of looks a bit scary, but it's not. You just plug in numbers, and then it makes more sense. Okay, are you good? Can I
mention something?
Yes.
So never mind.
Okay.
So we're supposed to find the value for x.
Oh, you're supposed to find the area. So you want to find the area of this triangle, and you have the values
Triangle?
up here. No, circle. Sorry.
But also, could we wouldn't it also make sense to find the values?
Yeah. So you would, I think a major step that you would want to take is first you want to identify the center of the circle based off of this equation. And this is kind of, if I'm being honest, this is like a little bit on the harder side to start with, I would say. But to give you a hint, I would simplify the left side of the equation first, and then I would simplify it in such a way so that you would get the standard form of a circle, which here I can type it down here, x minus h squared plus, is it k? No, sorry, it's y minus k. So that's the standard form of circle, and then what you would want to do is simplify this so you would end up actually getting this value down here.
What is h and k again?
H and k, that's the center of the circle.
H. Okay.
So I'll give you guys a little bit more time because this is a little bit, I would say it's a harder one to start with circles, and then we can go over the problem together.
16 pi?
That's close.
Wait, oh, wait.
Oh, you also use decimals? And where's the question?
Oh, the question, well, I wanted to show the circle, but okay, I think we can go over the problem now. But you want to, so you want to find the area of the region that is enclosed by the graph of the following equation.
I can't see it. It's loading.
Can you see it now?
I can see.
Okay, now I can see it.
Okay. So, so I just uploaded the solutions. But the 2x squared and the 2y squared terms make us think about the circle standard form, since expanding the squares on the left side of x minus h squared plus y minus k squared equals I squared will give us x squared and y squared. So we'll try to write the equation that we are given in this form. Whoops. And the first thing that you would do is you can see that all the least, or I don't know, I can't remember what the term is, but you can see that all of these numbers you can divide by 2. So then you would simplify it and you would get x squared minus 4x plus y squared plus 8y equals 2. And next, what you would want to do is add 4 and 16 to both sides to complete the square. So then you would get 2 quadratic equations. And if you were to add 4 and 16, you might think like you're adding extra numbers, but they would end up canceling each other out. So the values would still be equal to each other. But the 2 quadratic equations you get would be x squared minus 4x plus, there's too many pluses, 4 plus y squared plus 8y plus 16 equals 2 plus 4 plus 16. This would equal x minus 2 squared plus y plus 4 squared, and that's going to be equal to 22. This equation is in the desired standard form of a circle. So the graph of this equation is a circle with the center 2, -4, and a radius with the value of square root 22. So the area of the circle is square root 22 squared times pi, or 22 pi.
Can I mention something?
Yes.
I believe you wrote 2 plus signs in the first.
I pointed that, or I said that. I was like, there should be no 2. There should be only 1 plus sign.
First of all, there's too many pluses. Second of all, there's too many squares. I'm just joking. I'm just joking on that one, but seriously, it's a lot of squares to take in.
Stop.
Third thing is that
A
lot of it didn't make sense until you explained it.
Okay, I think once you figure out, once you see, oh, you're supposed to add in 4 to 16, and then you get 2 quadratic equations, and then you simplify it, I think it finally makes sense, because then you get the equation that you want to get that matches the original circle equation that we just talked about. So yeah, okay, I'll just leave it up here for a few more seconds, and then we can go on to the next slide, or next section. Okay. So next we have 17.3, which is going to be covering basic analytic geometry problems. So we're going to start off this section with problem 17.9. The shaded region's area between line K and the axis in the diagram is 36. If line K passes through 12, 0, what is line K's slope? So let's see. Hint, you could know that this is a triangle because this is 90 degrees, and then there's a line, so then you have 3 sides, hence it's a triangle, and you know that the area is 36, so you can based off of that, we also know that line K passes through 12, 0. So if you can find the other side, the unknown, let's say it's going to be segment AC. If you can find the length of AC, then you can find line K's slope, I would say. That's one way to approach it.
Can I explain how I did it?
Yes.
I want to explain too.
Okay, you can both explain.
Okay,
Um,
so first of all,
Take
the
turns.
area of the triangle is 1/2 AC times AB,
Mhm.
so which is 36. So AC times AB is 72.
Mhm.
And the length of AC is basically just the y coordinate of point C, and AB is just the x coordinate of point B. Line K passes through 12, 0. 12, 0 is the x intersection, and B is just also the x intersection. So B's coordinate is 12, 0. So AB is 6. And then because AB times AC is 72, so AC is 6. So C is 0, 6. And then you use the formula to find the slope.
Mhm.
And I will leave the rest for you, Kessler.
I wanted to say that there was another way. The shade, can I annotate? Dang it.
Can you annotate? I don't know if you can.
I can't.
Oh.
I wanted to annotate so I can give you a better. So the area of ABC, if you look closely, it's a right triangle. So the vertex of the right triangle of this angle is the origin, which is 0, 0. 0, 0, 0 x and 0 y, which is labeled A in the diagram. So vertex B is 12, 0. So we know that like AB is the length 12. So because the area of the triangle is 36, because of the height times the area times the height,
The base?
the base times the height. So we know that half the product of the legs of the triangle is 36. So AB times AC equals 72. And so AC equals 72 divided by AB.
Mhm. All right. Are you finished? Do you want to keep going, or?
So basically what it is AC. So what it is AC minus 0 over AC minus 0 over 0 minus 12, which is negative 1 over 2.
Yeah. So okay. Good job, both of you guys. So eventually you would figure out that C is 0, 6, and we already know that. And we also know that vertex B is 12, 0. So then you would use the slope formula, which is y2 minus y1 over x2 minus x1, and you can plug that in. So you get 6 minus 0 over 0 minus 12, and you would get negative 6 over 12, or negative 1/2. All right. So I will leave this up here for a few more seconds, because Kessler and Alvin basically just explained the whole problem, and then we can go on to the next slide. Okay. So next, for this problem, we want to find the number of points AB so that a squared plus b squared equals 25, and the area of the triangle that has points negative 5, 0, 5, 0, and AB as vertices is 10. Let's see if I can have a reference image. So this problem, you're originally supposed to actually imagine the triangle, or you could draw it out. So go ahead and try to do that. I know it's difficult to do that. I know if you guys are interested in math competitions, for example. I think it depends on the math competitions. I haven't taken part in too many math or like in middle school. I think I took a part in some, or maybe in elementary school. I can't remember, but not in high school. But from what I remember, there are some math competitions. Oh wait, high school? Yes, I did participate in some competitions. But depending on the competition, you might get a sheet of paper or not. So in case that you don't get a sheet of paper, there's some problems that prepare you to mentally think about the shapes.
So can I say that a squared plus b squared equals 25?
Mm-hmm.
Could you also say that it could be 5? It could be ab plus b squared equals c squared, and c squared is 5.
Mm-hmm.
It could be another right triangle.
It could be. Okay, I'll go ahead and post the answers. There are actually two different ways you could approach this. The first way would you would use algebra to figure it out. Okay, so for the first one, let's say, okay, so P is on either, here, there's also a reference image down there. P is on either y equals 2 or y equals -2. So B would have to be 2 or -2. So then when B equals 2, the equation A should be a squared plus b squared equals 25, gives us a squared equals 25 minus b squared equals 21. So then a is going to equal the square root of 21 or the negative square root of 21. So two possible points for p, that's going to be square root 21, 2, and negative square root 21, -2. And similarly, when b equals -2, 2 points are going to result if you use the same method. So then you would get square root 21, -2, and negative square root 21, -2. So there are 4 different points. And for the second one, you would apply geometry. I think this solution is, I think it's probably easier, I would say, since we are talking about a triangle. So AB would satisfy the equation x squared plus y squared equals 25. So we know that AB is on the circle centered at the origin with a radius length equals 5. So Kessler, you previously pointed that it could be a triangle, but then at the same time you can also think of this as a circle, this equation, because the circle's origin is centered at 0, that's going to mean that x minus h squared plus y minus k squared, that's going to be x minus 0 squared plus y minus 0 squared. So that would end up just being x squared plus y squared equals 25. So that would result in a circle with a radius length of 5. So we also know that AB is either on line y equals 2 or y equals -2, and each of the lines is 2 units from the circle, so both lines go inside the circle. Hence, both lines intersect the circle 2 times. Each of the 4 points of intersection between a line and the circle gives us a point that satisfies the conditions given. And those 4 points would be these 4 points up here. So it would be square root 21 to negative square root 21 to, I think I accidentally put one too many negative signs up there, but this one would be negative square root 21, negative 2, and then this would be square root 21, negative 2. So I will get rid of this negative. Here we go. Okay. So, okay. I think the first one, the first solution didn't really make much sense at all. It's kind of more just like, I don't know, it's algebra, you're applying algebra to geometry. I mean, it could of course work, but since we are dealing with geometry, I think the second solution just makes a lot more sense. And I think with the image too, it would make sense. So I'll leave this up here for a few more seconds and then we can go on to the next slide.
I feel like solution 2 makes more sense.
Yeah, so solution 1 is just, I don't know. It's applying algebra to geometry. But I think, like personally for me, I'm just a visual learner, so the geometry solution would make more sense for me. Yeah, and then like algebra is just, you know, dealing more with numbers. So yeah, the geometry solution makes more sense. Okay. So next we're going to problem 17.13. In triangle ABC, AB equals BC, AB equals BC, and that equals 8, and angle ABC equals 45 degrees, and we want to find AC. So that would be, you would draw AC down there, and you know that angle ABC is 45 degrees, so that should tell you something about the triangle that is formed. And then once you figure that out, you can use the special properties of that specific triangle to also figure out AC. And you know that AB, which is equal to BC, that's going to be equal to 8.
Isn't angle ABC technically 1/8 of 360?
Yeah, it is. Yes.
My brother came over and he tried to sabotage
You
my
mean AC the line or AC the arc?
Oh, AC the line.
AC the line. Okay. No, stop, Coulson.
He said "gugu," which means brother.
Now we need to teach him a lesson.
He said "gugu, gugu."
Coulson, you need to learn math.
What's his name?
His name is Coulson.
Just have.
All right. Once we finish this problem, we can go on break. So there are, I'm pretty sure you could have, I just put one solution, I think, for this one. There is another way to do it, but the second way just kind of, it stemmed off of the first one, so I just went along with the first one. So the first one, you use analytic geometry to figure out this problem. So the 45 angle might make us think about analytic geometry, since the line y equals x of the graph makes a 45-degree angle with the coordinate axis. Also, AB, which is equal to BC, which is equal to 8, means that A and C are both on the circle with center B and with a radius 8. If we let B equal the origin, then the coordinates of A and C are solutions to the following equation. X squared plus y squared equals 64. Since the equation's graph is the circle with center, that is the origin, and there should be an S there, but the radius equals 8, so 8 squared equals 64. We know that the graph y equals x makes 56 degree angles with the x. It should be 45, not 56. I guess my hand slipped when I typed that. Okay. That not 40, not 56, 45. But it makes a 45 degree angle with the axis. So we're going to let C be the long x-axis at 8, 0, and A be on the graph of the line equals y equals x. I have no idea what I typed there, but yeah, so C is going to be along, I think I meant to say along, but it's going to be along the x-axis. Okay, and we're going to find the coordinates of A by drawing an altitude from A to the x-axis, or by using the equation for the circle. Since A is on both the circle and y equals x, we're going to find the coordinates of A by subtracting y equals x into the circle's equation. So this is going to give us x squared plus x squared equals 64, because we know that y equals x. So then x is going to equal 4 times square root of 2, because you would add up the x squareds. So then you get 2x squared equals 64. And then you would just simplify from that point. So point A is 4 times square root 2, 4 times square root 2. And we can use the distance formula to find the following, which is on the next page. I'll go back to the previous page if we need to. But it's going to be AC squared equals square root 4x squared minus 8 squared plus 4x squared minus 0 squared. Remember that it is x2 minus x1 squared plus y2 minus y1 squared. So then that's going to be equal to the square root of 32 minus 64 times the square root of 2 plus 64 plus 32. And that's going to be equal to square root of 128 minus 64 times square root of 2. And that would be finally simplified to 8 times square root of 2 minus square root of 2. So there is a square root inside of a square root. Just keep note of that, but that's because one of the points that we used was the square root of 2. So that would be how we would get our final answer for AC. So what we did exactly was, we could see that this is at 4 times square root of 2, 4 times square root of 2, and the radius is going to be 8. No, yes, it's going to be 8 units long. So yeah, basically you would plug those numbers in to get the final answer. Okay. I will go back to the first slide so that you can go over these solutions, and then we can go to the next, and then we can take actually a break for 5 minutes.
I thought you already gave us a break.
No, not yet. Okay. And then the last part of the so the problem was just plugging into the distance formula. So I think that's I'll just show it for a few seconds. Okay.
I'm just wondering if Izzy knows that we're all just chatting about siblings.
No, I don't.
Yeah, we were in the
Wait, what's going on now? Is it break?
Yes.
Okay.
Jinx.
Wow, he destroys every part of the computer because I'm just going to the chat now because that was a lot. It was like 15 years old, so it's still expensive. At least I got a new one. Have you got defenses? Frames. Pillows, pillow walls, plushies.
Plushies are just stuffed animals. But seriously.
Okay. The
Oh,
sibling.
you
Yeah,
built a
okay,
machine that drops a weight on him?
Okay, Elika, you took it too far. You took it too far.
How about you make a machine that drops away on your sibling every time you do something bad?
I want to see that machine. That's
Izzy, this snake, he destroyed half of it, and then
Wow.
and on the Lego set, it says it's 463 pieces.
Wow.
And that's 31.5 pieces he destroyed.
That's crazy.
Oh, okay. When you mean by 0.5, you mean that he used his knife, cut a Lego brick in half, and then destroy one half.
I'm just dividing it in two.
Oh my god, that is so mean. That is so bad.
And today I almost got in trouble because my brother sabotaged my meeting 10 times. Even though I banished him to my parents' bed.
And then you came back.
He came back because, as you can see, he's very energetic.
Yeah.
And he likes, yes, he is very energetic, I believe. I believe everything you're saying.
And he just had ice cream. Ice cream
Oh my gosh.
plus babies equals ice cream plus
Okay, I used to always want to have a sibling, but now I guess I'm gonna change my mind. Maybe I'm not gonna have have a sibling.
even though we're actually talking about the bad side, some of the times it's real I'd say it's really good. Having a sibling is good. It's just because
Yeah, I'm lonely. My mom has to work, and I don't want to disturb her, but I have nobody to play with, you know.
Yeah.
about a dad.
Yeah. I'm also a single child too, so I don't have any siblings. You know, like
Sometimes I feel
Boom
like
shakalaka, defeated.
A bunch of other things that
Yeah, defeat the enemy.
sometimes I feel like having a brother is a curse, but at the same time it's a blessing. Because a all the time.
Boom shaka.
And
Alright.
kids
Next enemy.
plus sugar equals parents and older siblings' worst nightmare.
Boom.
Did I get kicked out again? Yes, I did. I don't know why my Zoom keeps doing that. Okay.
Can you still screen share? Make sure you can still screen share.
Yes.
Okay, phew.
Phew.
Okay.
And
So
wait a minute. He's coming.
he's coming. Okay. So for 17.4,
Speeding my enemy.
we're going to be dealing with analytic geometry proofs. Hopefully your brother doesn't
Okay.
do anything. Okay. So just a mini review for the next problem in case people have forgotten. The circumcenter is the center of a triangle circumcircle. A circumcircle, that's going to be the imaginary circle that is drawn, and that circle is going to touch all three vertices of the triangle. And the circumcenter can be found as the center of the perpendicular bisectors, for example, in this image down here. Okay. So this is problem 17.14, and we want to use analytic geometry to prove that the midpoint of any right triangle's hypotenuse is the triangle circumcenter. Ignore the up there.
Use analytic geometry to prove that the midpoint of any right triangle's hypotenuse is the triangle circumcenter.
Yes. So I just put this image down here. This is part of the solutions too, but it can also maybe help you guys to maybe try to come up with some ideas as to how you should figure out the problem. Okay. So the first thing that you want to do for this problem is to set it up on the Cartesian plane. And we can start by letting A equal AB, B equals CD, and C equals EF, but that's 6 variables. And maybe we can find a way to represent triangle ABC in a simpler way. So when setting up a geometry problem in the Cartesian plane, we want to start with a diagram, then add the coordinate axes. So we can choose any point to be the origin. So we set one of the vertices of triangle ABC to be our origin, because I think that's like a very efficient way to set up a triangle. And you want to choose point C to be the origin, since this allows us to choose our axes so that the right triangle's legs are along the axes, hence the reason why it's one of the most efficient ways. So you're going to let A equal A0 and B equals 0B. So notice that A and or B could be positive or negative, and you can notice that in this image where the triangle was actually flipped, and B would be negative and A would be negative. So looking at the example, both A and B are negative. Because C is the vertex of the right angle, side AB is the hypotenuse. We're going to let M equal the midpoint of AB, or A divided by 2, comma, B divided by 2. Remember, that's our midpoint formula. In order to show, or it would be the average of 2 different points, if you can remember that. But in this case, it would be A divided by 2, comma, B divided by 2. In order to show that M is triangle ABC circumcenter, we must show that M is there another image? No, sorry. Sorry. Okay. We must show that M is equidistant from all of the vertices. And we prove this by using the distance formula for the 3 different segments that would appear, because M would be the midpoint of AB. So AM, that would be the square root of A divided by 2 minus A squared plus b divided by 2 minus 0 squared. And you would simplify that to get the square root of a squared plus b squared divided by 4. Bm is going to be the square root of a squared minus 0 squared plus b, did I say a squared? A divided by 2. B divided by 2 minus b squared. And that's going to be simplified, and you would get the square root of a squared plus b squared divided by 4. And finally, Cm would be the square root of a divided by 2 minus 0 squared plus b divided by 2 minus 0 squared. And that would equal the square root of a squared plus b squared divided by 4. I guess I should have mentioned this in case you guys have forgotten, but notice how the distance formula is, remember, it's x2 minus x1 squared plus y2 minus y1 squared. So with that, we can see that all these three lines are equal to each other. So M is the circumcenter of triangle ABC. And note how every step in our proof is valid, even if A or B or both of the variables are negative. Okay, I'll leave this up here for a few seconds and then we can go to the next slide, which is just more information, a little bit more information. Okay, so this is important information. When you're setting up a geometry problem on a Cartesian plane, make sure that you choose your origin and your coordinate axes wisely. We make these decisions in a way that makes the coordinates of important points in the given problem as simple as possible. Okay, so next we have problem 17.17. Suppose line K divides rectangle ABCD into two pieces that have equal area. Prove that line K passes through the intersection of ABCD's diagonals.
Where is line K?
Line K is, so that's what you're actually trying to figure out. So they don't supply an image of line K because you can divide the rectangle differently. So first you want to make sure that line K, you want to establish a line K, and then make sure that it splits the rectangle into two equal pieces of area. And then you also, once you determine where line K is, then you want to prove that line K passes through the intersection of ABCD's diagonals. So basically, that just kind of gives away where line K could be. Or it would, I think it's a big hint, because if it has to pass through the intersection right here, then there are not too many options as to where line K could be.
Actually, in some other class, I learned that if you want to cut a shape in half, the only way to cut it is to draw a line that passes through its center. So
yeah, exactly. So it's I will give an example of just different ways that line K could be arranged, but it wouldn't necessarily prove that line K passes through the intersection of the diagonals. But yeah, just to get a broader image of how line K could intersect the rectangle and what kind of shapes or what kind of shapes will result. Okay. So this solution is actually pretty long. So we can go ahead and get started. It's pretty easy to describe a general rectangle with coordinates. We're going to let A be the origin and choose the axes so that 2 of the 4 sides are along the axis. Since ABCD is a rectangle, it's also a parallelogram, so its diagonals bisect each other. So we want to prove that K passes through AC's midpoint. Hence, we let B equal 2B0 and D equals 0 to D. Point C is on the vertical line through B and on the horizontal line through D. So C will be 2B, 2D. The midpoint of AC will then equal BD. Now that we've dealt with ABC, it's time to take care of K. First, we have to think about different ways in which line K could intersect the rectangle. If K intersects 2 consecutive sides, then the area of the triangle that it forms is smaller than the area of the triangle formed by drawing a diagonal. So we're going to use an example. If we look at the diagram on the right, we have the area of triangle AXY is less than the area of the triangle ABD, and that would equal ABCD divided by 2, because you can see that ABD covers half of rectangle ABCD. So it's not possible for such a line to bisect ABCD's area. This line K cannot be there. So if we follow similar logic, if line K passes through a vertex of ABCD and bisects ABCD's area, then line K must contain a diagonal of ABCD. So line K passes through the intersection point of the diagonals. Another possibility is that K intersects the opposite sides of the rectangle, not including the vertices. Let's see. Here's the image. You can see that line K is intersecting the opposite sides of the rectangle, so that's what the solution is talking about. So line K intersects AB and CD at P, P0, and Q, Q2D as shown. So if we go back to the image, there is P0 and then there is Q, and that's P, comma 0 and Q, comma 2D. If K bisects ABCD's area, then it splits it into 2 trapezoids that have equal area. So we can see that there are 2 trapezoids. Okay. I apologize for the inefficient way that I set up the solution, but I was kind of running out of space in case you guys might have noticed. So I just put the image on the last slide, but yeah, okay. So the trapezoid APQD's bases have lengths P and Q, and APQD has height 2D. So the area of APQD will be 2D times P plus Q divided by 2, and you'd simplify to get D times P plus Q. So if we go back, if we look at trapezoid APQD, you can see that the lengths are P and then Q, and then the height would be 2D. So we just plug those 3 values in to figure out what the area of the trapezoid was. So the bases of PBCQ, the other trapezoid, have lengths 2B minus B and 2B minus Q. So the area of PBCQ is going to be 2D, same height as the first trapezoid, times 2B minus P plus 2B minus Q divided by 2. So if we go here, you can see that we subtract 2B minus P because we don't need this length, which is P. And then we would, up here, we would subtract 2B minus Q because we don't need this length. And yeah, we just follow similar the similar set of steps that we went through when we figured out the first trapezoid's area. So if we set these equal to each other, we get D times P plus Q, which is equal to D times 4B minus P minus Q. Divided by D gets us P plus Q is equal to 4B minus P minus Q. So 2 times P plus Q equals 4B. And finally, we find that P plus Q equals 25. But how is this going to help us? We want to show that line PQ passes through AC's midpoint. So remember that AC is a diagonal, and the whole purpose of this problem was to figure out, or is to prove that line K does indeed pass through AC's midpoint. So AC's midpoint is BD. Since we know that P plus Q equals 2B, as we got from the two trapezoids, we see that the midpoint of PQ is P plus Q divided by 2 and 0 plus 2D divided by 2, which is DD. So line K passes through the intersection of ABCD's diagonals. Okay. That was a lot of information. So to sum it up, because I think it just would take more time if we went over the 3 different slides. Basically, first what we did was try to figure out where K could be. Notice that you could also, K could be, it could have a negative slope, so it could have split the trapezoids would have been split differently, but you would still get the same results in that you would be able to prove that line K passes through the intersection. But yeah, so first you determined, okay, I need to figure out where line K is. A big hint was that it passed through the intersection of the rectangle's diagonals. So then once you establish K, you would find the area of the two shapes, whatever shapes are resulted based off of how K was positioned. And then you would simplify them, or you would make them equal to each other, simplify that to get a final equation, P plus Q equals 2B. And finally, you would use the information that you already know about AC's midpoint along with the equation that you get to figure out what the midpoint of PQ is. And since you know that that's going to be equal to BD and AC's midpoint is BD, that means that line K has to pass through the intersections. Okay. So next we have, I believe, oh no, it's actually not our final section. So we would wrap up chapter 17 in our next class. But this section is going to deal with the distance between a point and a line, but it's currently 8:13, so we can go ahead and actually go to Kahoot. We can leave the PowerPoint presentation because the next two chapters that we're dealing with, which are going to be our last 2 chapters, they are on the shorter side. So yeah, we'll have plenty of time to figure out the different. We can just go through the remaining sections that we need to go through. But this is the moment that a lot of guys seem to be waiting for, playing Kahoot.
Who's Howie Bowie Wowie?
Isn't that Howie? I don't know.
Okay, so Alika 11 is Alika 11.
Elika. Elika.
No, Alika is Alika 11.
Yes. Yeah, you put. Where did Alvin? Is Alvin going to join? No.
Oh, I know exactly who he is.
Yeah, like it's just a combination of a hypnoshroom and a citron.
Why would you want hypnoshroom and citron? Wouldn't it make more sense to do the hypno flower? from Garden Warfare 2. It's much
I mean,
stronger.
I did the hypnocitron because because I was originally gonna do Gatling hypnocitron, but it didn't work. Too many characters.
Okay. This is a rolling. You can join anytime.
No. My brother's trying to destroy my Lego again.
Oh my gosh! Maybe you can pause it. Maybe the teacher can pause and then let you go destroy your brother. Yeah.
Nice.
Wait, not ready.
Are you good now?
I'm in 4th place.
Okay, I'm ready.
Okay.
Midpoints. Find the area of the gray figure in square units.
Wow.
Which square?
That is so easy.
The gray figure is just the entire shape.
I'm jumping for no reason.
Why do you jump? Why do you?
I do not know. I am jumping for no particular reason.
Good for you.
Good for you.
One person got it wrong.
Me?
That's not good because I advanced.
I do not know what happened because I literally chose the correct answer and the computer probably just glitched out. This has 24.
Square A has a perimeter of 24. Square B has an area that's 1/4 of the area of square A. Find the perimeter of square B.
Okay, that is complicated. I want to get revenge on the Gatling P. Good thing I only got on the second question, so there's no streak, so I don't really lose any streak points.
Wait a minute, I forgot it. Oh, I got it correct.
What?
I got it.
I am right behind you. One question behind you.
I got it wrong, but I got it correct.
Okay, I'll sit the larger.
A, C, and D are midpoints. The larger square's area equals 60. Find the smaller square's area.
You know this is the easiest question I've ever done. One of them. One. This is one of the easiest questions ever in human history. 25.
Dang it, I got it wrong.
Thank you.
No, it's because
You lost your streak, but I didn't get.
I
I went ahead of you because I didn't lose any streak points, but you lost streak points.
The only thing you will lose right now is your mouth because I'm going to punch it off.
Oh my god.
No.
你们在上课，怎么跟人瞎聊天
？1/4, 1/4, 1/4, 1/4, 1/4. Yeah, I try to hypnotize people, and I really did.
I got it wrong.
It's true. My controlling is true.
I got it wrong because the computer glitched out. I hit it, but the problem was it glitched out at the last second, so I got the wrong answer.
I am fully convinced that my controlling is true. I hypnotized you.
What's the largest possible area of a right triangle with the side lengths of? What's the length?
With side length 12 and 20.
So So.
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 So. Your mom is yelling at you.
I know.
No. This is gonna be a curse. And there's still that one guy who has not yet to answer.
Nice.
Socks up, boobs in a mouth, bow wow wow. I do weird things.
That's from BTS, isn't it?
What is the smallest possible area of a right triangle with two sides measuring 4 and 5? Oof, 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 oof. Oof, 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 oof. Oof, oof, oof. Okay, I'm telling you, the answer is my favorite color. Nobody knows my favorite color.
And actually, the answer is also my favorite color.
It must be orange then.
Come on. Oh my gosh. I was reading in my mind 812 812. I was reading in my mind 812 812 and trying to hypnotize them with my mind without saying anything, and that really worked.
AB equals 12, BD equals 13, 15, and BC equals 17. What is the area of the quadrilateral ABCD?
So basically, you have to add the right triangles areas.
Ha, 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 ha.
Why are you hiding?
If you flip it, then it's basically a rectangle.
Thank you for telling me.
You know that all I was doing.
Wait, no. How do you know that these triangles can make a rectangle?
Because
What
I
if-
can just literally flip it and see that.
Yeah, but sides are deceiving.
Ha, ha, ha.
I do not believe you. I will do it.
Tricked by the police. Yee. No, still no.
That is 54.
Oh,
I did not say anything right there.
I'm the only one who's answering, and anyway, people are still not good. And yep, the answers are always coming at the last second when it's
nice.
Yeah, looks are deceiving. It's not a rectangle. I proved it's not a rectangle.
Triangle ABC is an isosceles triangle with side lengths 25, 25, and 48. What's the area of triangle ABC? Well, what do you think?
I am not gonna tell you the answer,
I'm not going to give a thing about it.
but I know the answer.
The only way I think you're knowing the answer is just by pure durs. Just pure durs. You're just like You say so much ers that people will think you're a seal.
What did I say? I did not say any ers.
Yes, you did. You did rs. You did them.
I said
You did them rs.
I was saying
Ow.
Here comes Superman.
Here comes cringy guy.
And I just answered the question.
Hypnocytron does not work.
Find AD. What the?
What the? Art.
Literally remembered from the last question that I had to do 25 squared minus 24 squared, and this I have to do 25 squared minus 7 squared. It's just the same thing around.
25 squared minus 7 squared.
Is, come on, the answer is 20. Okay, fine.
What's the perimeter of a rhombus with diagonals of length 12 and 16?
What the?
What the First
First one to answer.
First one to answer is a rotten egg.
What? Shouldn't it be the last one to answer the rotten egg?
No, just because they're the last one does not mean 30, 50, 30, 20, 40.
Hi, Superman.
Superman.
You know, Superman's flying right above my head. Hi.
你会在上课还是在来家？
What? I keep misclicking.
Wow, Alika.
Wow, yeah, totally.
Wow. And I think that's all of the questions she will get right.
No, maybe have faith in her.
A tile measures.
Tile measures 3 inches by 4 inches. How many tiles? Blah 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 blah.
Shut up.
How many?
I am never shutting up. Ha 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 ha.
Somebody help this man. Somebody help this man. 2 feet by 5 feet.
Okay, did you just slip again?
Yes.
Oh my gosh, Elika actually got it wrong. I think I can catch up to her with my streak.
It is impossible for the perimeter of a square to equal the number of square inches in its area. It is impossible for the perimeter of a square to equal the number of square inches.
It's false.
False.
That was easy.
Somebody pick true. No, I move up. So not me.
So when
And
it
I
comes
cannot hear you.
to dealing with true or false statements in math, statements. Okay. Oh wait, 3 of you got it. Okay, I thought 3 of you got it wrong.
What the?
Okay.
But,
I do not hear you.
the square
Can't
that
hear
basically
you.
like. Okay. Are you talking to me or are you talking to Kessler?
Whoops, sorry. I muted my audio.
Ah.
What did you just say?
But yeah, the square that would go against that statement was, the 4 by 4.
Find the length in inches of a square where its perimeter and area values are equal to each other. Find the side length in inches, the perimeter and area value.
6, 6, 6, 6, 6, 6, 6, 6,
Bro, you
6.
dumb, it's not 6.
没关系。
Well, you're not dumb, but you're just not, it's not working. See?
Okay, fine. It's not gonna work. And the streak actually worked.
See, I told you. That's how many questions Alka is going to get right.
Yeah.
Diagram, what is the value?
Value of x.
The value of x is the value of x.
The value of x is the value of x. That does. I don't think that makes any sense.
The value of x is the value
Does
of
it say 48? I think it says 48.
Yes.
Okay.
I'm still trying to get this
The
out.
answer has 4 sides. Yeah, I said they had 4 sides and one person chose 150. Okay, how am I second place?
Sure. Alika beat you. Wow.
Wow, by the time.
Good job.
Come on, the streak doesn't work.
See, you can never underestimate anybody, because you might think, oh, somebody was Jack.
We still have
Okay.
45 minutes left. Can we play another Kahoot? Because it only took 15 minutes. You owe us another Kahoot. So technically it makes sense for us to get another Kahoot.
No.
Yes.
Yeah, it's 8:30, which is the end of class. Maybe for class 19, we could play 2. Well, it just depends on how much time we have, but we could play maybe 2 Kahoots for class 19.
Can we just play for the class 19? Can we just play all Kahoots?
We have to cover a chapter. Adrian's going to be in charge of the last class, so it's going to be, he will figure out what you guys are going to do, but yeah, so you guys can maybe ask him if he could do some Kahoots, maybe more than one. Okay, so it's 8:31, so that's the end of class, and I will see you guys next time. So
Bye.
bye, good night, good morning, wherever you are.